And let's start with the first speaker, Warren Russell, Chief Commercial Officer at Moleaer. Warren is an experienced entrepreneur with over 15 years of business management experience in the wastewater treatment and environmental services industries of Southern Africa and the Middle East. Prior to leading the commercial efforts for Moleaer, Warren, a graduate of the University of South Africa, founded Aerofit USA and Evergreen Technologies, which focused on environmental consulting and designing wastewater treatment processes for municipal, industrial, oil, and gas applications. The title of his presentation is Nanobubble Technology Optimizes Aquaculture Systems. Warren, hand it over to you.
Good afternoon, everybody. I appreciate everybody's time and attention today. My name is Warren Russell. As it was introduced, I'm the Chief Commercial Officer of Moleaer. I'm going to kick this off and explain a little bit about nanobubbles, what we do as a company, and how they can be utilized in the field of aquaculture, and specifically hatcheries in this moment. A quick introduction about nanobubbles, a little bit about our company. We are based in Los Angeles, in California, in the US. We do consider ourselves sort of a global leader in the manufacturing of industrial scale nanobubble systems. We operate in a large number of different countries. Currently have deployed roughly around 1,800 systems in a variety of different applications, ranging from horticulture, treating irrigation water, to algae-controlled surface water, and that may include everything from shrimp hatcheries to open ponds, and also oil and gas and other applications that all are centered around the role of nanobubbles in different processes that basically deliver some kind of enhancement to efficiency of use of those resources, or improving the recovery of those resources in certain ways. So a little bit about nanobubbles, real quick introduction. It is a scale of the size of the bubble. That scale of the bubble in our context is roughly about 120 nanometers in size. That's extremely small. It's around 2,500 times smaller than a grain of salt. And what's unique, once you get a bubble down to that size, it actually retains more about the properties of a colloidal particle than actually a bubble itself. And once you have this bubble at a certain scale, it does become stable in solution, just like a colloidal particle. And one of the principal reasons why that bubble is stable in solution is relative to its electrochemically charged surface. So it's a negatively charged particle that gives it sort of repulsion and keeps it stable, just like a colloidal particle. But it's that charged surface that provides some very unique properties as it relates to treating water in certain ways and enhancing different kinds of processes along that way. And one of the best examples of that exact benefit of a nanobubble in solution is its ability to disrupt and remove biofilm from surfaces. So as you know, in any kind of surface to liquid contact, you have the development of bacteria that establish biofilm, which can be very stubborn and difficult to remove from those surfaces. They can harbor pathogens and certain types of unwanted bacteria. And what we found is the role of having nanobubbles moving through a system is very effective at disrupting those biological matrices from those surfaces and helping to bring them into bulk solution where they can be removed when activated through other processes. Just a quick idea about validation. If you're looking at a glass of water with nanobubbles, we're talking about concentrations that could be up to hundreds, if not billions of nanobubbles per milliliter of water. It's an extremely high surface area, but you cannot see them. So one of the best methods that we use, and is a well-established method of not only classifying size and concentration of those bubbles, is an instrument called the nano-sized. That's a laser particle analysis. It's very commonly used in different universities looking at particles in solution. We use this, and this is how we validate not only surface charge, but the concentration of these bubbles. We do use our technology to deliver a wide variety of gases, depending on the application. Obviously, in aquaculture and hatcheries, we focused around the role of delivering oxygen very efficiently. and we have gone through various kinds of validations, particularly from our background in water treatment, looking at how we can utilize nanobubbles to deliver and dissolve oxygen very efficiently into solution. One of the key takeaways from that research is that not only is it a very efficient method of injecting gas into solution, but it also is not susceptible to some of the limitations that conventional aeration or oxygenation devices like diffusers may have with regards to other inhibitory compounds in that water that diminish the concentrate or the dissolution of gas into solution. The other role of nanobubbles is that it can be used for the removal of certain kind of contaminants, and that is utilized through a combination of fractionation and oxidation, utilized from these bubbles as they may be able to remove certain kinds of particulate from solution, as well as oxidizing those contaminants. One of the key overviews about nanobubbles as it relates to our core technology is we essentially are bringing in water at certain flow rates. We have a pretty wide range of styles of systems that deliver various kinds of flows to meet the capacities of a particular system. But what's unique about this process is that we're actually injecting two forms of gas into solution. One of which is the immediate dissolution of the gas as we're injecting it, but the other is also the production of these nanobubbles that will become stable in solution. The benefit of that is you have a very evenly distribution of dissolved gas in solution, as well as the ability of increasing and elevating that ORP uniformly in that water column. And that ultimately has some pretty significant benefits as it relates to the general water quality or water quality improvement that the system can deliver. Just to give everybody a sort of a quick overshot of what these systems may look like, they are purpose-built systems. Depending on the application, depending on the market, you may find different needs and wants out of a particular system. The Neo, for example, is a turnkey system that delivers and injects its own oxygen into that system. The one that we most commonly use is this Nexus style inline system. And the idea is, especially as you see the movement towards more recirculating systems, the ability to integrate oxygenation with inline recirculation is highly advantageous to being more efficient with your energy and overall operating costs of that system. And just to give you a quick overview of what that may look like in field and practice, you're looking at a couple of inline systems that's either taking a side stream of an existing higher flow of liquid, using a gate valve to provide a negative pressure, and the diversion of that flow through a core technology. And why that's highly advantageous is obviously we're utilizing the existing energy that's already inherently part of a recirculating process. And in other cases, you're either replacing or retrofitting against other sort of either could be outdated pumps or conventional oxygenation systems that are not meeting the capacity needs of a particular system. So in many cases, you could look at this as a supplemental source for improving the oxygen levels or sort of the dissolved oxygen saturation points of a system. You could be balancing to a certain set point so that you're optimizing your feed conversion ratios. Alternatively, you may be looking at this to introduce nanobubbles in a way to promote the water quality in some capacity. Each system, whether it's delivering oxygen through diffusers, cones, venturis, or sparges, they each have their strengths and weaknesses. Here, what we're really focused on today is not only the efficiency of that gas transfer, but really the role of the nanobubbles as they may improve both or reduce disease pressures and other water quality metrics that may be important that are not well served by other conventional methods of oxygenation or aeration. What we see as a sort of the key driver is certainly sort of from inbound from the customers is the drive for more efficient means of those resources. So if you look at increasing energy prices in Europe or globally for that matter, high energy pumps, high energy systems to either recirculate or provide oxygenation. There's a driver to do that more efficiently. And then particularly as you're moving towards more land-based grow-out systems and RAS, again, a strong driver for each one of those processes to be more efficient. And here we're looking at the role of nanobubbles in improving things like the protein removal through that fractionation and deemulsification of sort of those unwanted compounds that are in solution. We're looking at utilizing those nanobubbles to promote biological nutrient removal, specifically ammonia oxidation, as well as the mitigation of H2S. And that comes back to the role of the nanobubble being able to disrupt those biological matrices and other dead zones where these bacteria can reproduce. Also, as it relates to the role of these systems driving towards higher stocking densities, intensification of systems, generally in conjunction with those sort of demands, you come with more constraints on the system and being able to maintain high water quality, as well as just optimizing the gas transfer to support those higher demands on the system. And then, of course, the welfare of the fish, maintaining better quality of water, maintaining better oxidation potential of that water, and minimizing the disease pressures through those poorer water quality metrics. So as a whole, we see the big demand within the industry to look for the more efficient utilization of these gases to support better oxygen levels, to maintain better feed conversion ratios, all the while driving towards intensification and better use out of those given infrastructures. Our system is used in a pretty wide variety of applications and types of facilities, everything from flow through and smolt production to core systems, open ponds, as well as smaller contained systems. Again, the benefit, whether it's a flow through and you've got, in some cases we have examples where water has higher levels of nitrogen, other gases in solution. We need to remove or displace some of those unwanted gases to bring the total partial pressures of that oxygen back to a regular level. Or alternatively, in some cases like this, where we're injecting ozone nanobubbles to really maintain or mitigate any disease pressures that may be coming through that system. And then, of course, the most obvious of which is efficient oxygenation within these systems. Recirculating aquaculture systems, the demand typically is sort of modulating the oxygen control in each system. You'll find that quite frequently you have different biomasses in different cells, and the ability to very finitely maintain oxygen levels within that system in the most efficient manner, in a way, and creating all these sort of better metrics with regards to the water quality. But again, where we see some of the best opportunity and for the role of nanobubbles relates to enhancing these treatment processes within a recirculating system. And specifically, I'm talking about better particulate and protein removal through the protein skimming, as well as better ammonia, better efficient removal of ammonia as well, and then obviously the mitigation of some of those H2S factors. I've thrown in a couple of case studies here just to give you a perfect overview of this is one of the best examples of a sort of a holy grail of what we try to accomplish with our core technology. Here we have a recirculating hatchery in Canada that we did a retrofit on. Basically what happened is the existing LHO was battling to maintain dissolved oxygen levels throughout the system due to the increase in biomass that they were maintaining in the system. We did a retrofit, added oxygen nanobubbles to this facility. Not only were we able to demonstrate a reduction in the amount of oxygen used, but But within that, being able to maintain that higher saturation point, we're able to convert that to a higher feed conversion ratio. And when you look at that ratio and metric relative to the amount of oxygen utilized in conjunction with the mass or weight gain over this particular interval of 30 days, you see a pretty substantial increase of 48% over and above the conventional system. So that's one of the best examples of what we aim to do. Then alternatively, retrofitting cones. Cones in their ideal situation can be a very efficient means of oxygenation. In practice, though, we find that a lot of installations are not operated correctly, and generally the limitation with the ramp up and ramp down and just those ideal operating parameters are not typically met. This is an example of a project we did in Chile where we did a retrofit of a cone to support about 10 tanks with salmon smolt. And here you see a pretty substantial reduction in both oxygen utilization and energy being one of the biggest drivers for that cost savings to the customers. Just one more example here of another flow-through hatchery. This particular example is in Chile as well. Here you had the feed water coming in with a higher level of dissolved nitrogen in this water. They didn't have degassing capability. So what we had to do here is do supplemental oxygenation, but operating the equipment in a way where we could both dissolve the oxygen in solution, but also strip some of that nitrogen out. And we were able to reduce this dissolved nitrogen down from 106% down to about 96% saturation. So overall, a pretty substantial reduction in nitrogen in conjunction with the increase in the oxygen. And we attribute that largely to the increased partial pressure of the gas, or the higher partial pressure of gas inside that solution. And just lastly, just a couple of last points here. Ozone, again, alternatively as a comparison against introducing ozone through nanobubbles compared to the most conventional, which is Venturi, opportunity for much better half-life and saturation rate of ozone, but also most importantly, off-gassing. You can see that comparison of very substantial reduction of off-gassing, which again, if you're utilizing ozone in your system, that can be a health and safety risk if you can smell it. So we want to minimize that off-gassing and maximize the treatment potential of that ozone. And then lastly, on the ammonia removal, here we just have a perfect example of a comparison, equal levels of dissolved oxygen, looking at the biomass kinetics and how these oxygen nanobubbles can improve that ammonia oxidation. So if you're looking at your biofiltration, biological nutrient removal, you will see about a 15 to 20% improvement in capacity. So if you're aiming to increase your stocking density with your existing infrastructure, the ability to remove ammonia more efficiently with oxygen nanobubbles can be a significant benefit. And another one, which not so picture on hatchery unless you're doing grow outs, but again, just an example of how nanobubbles can actually help to remove these targeted unwanted compounds. In a case of grow outs, you have MIB and jasmine, and here we just through university research have demonstrated a very effective way of just these oxygen nanobubbles on their own being able to remove all flavor compounds from that solution. And so I'll just wrap up. I mean, a pretty wide variety. We're utilizing our systems in all parts of the world, different processes, different kinds of fish. But again, I would point you to there's some great research coming out globally. And if you're looking at either ozone nanobubbles in a ways to mitigate diseases and disease pressures, to fish health, I've just thrown up a couple of examples that are fairly recent here, and you can see whether it's water quality improvements, immune responses in the fish, stocking density, better water quality metrics throughout. Each one of these papers will talk to those kinds of benefits, and so I welcome people to continue to research, and there's great work being done on the global base. And I thank everybody for your time today. And please let me know if you guys have any questions at the end of the presentation.
Here's a question for you. Does high level of DO from nanobubble contribute to the gas bubble disease?
No, it does not. That's a relative question because it depends on the amount of dissolved oxygen and the other partial pressures of the gases in solution. So hypothetically speaking, a lot of the gas bubble associated questions come from when there's elevated nitrogen in the water. So as long as you're managing your nitrogen levels in the water and you're not exceeding your oxygen by a significant degree, so hypothetically speaking, in most cases, farmers are aiming for anywhere between 80 and 100% saturation of dissolved oxygen level. And as long as you're managing your DO accordingly, there should be minimal risk to gas bubble disease.
What additional benefits have you observed from nanobubbles in hatcheries that may differ from dissolved oxygen?
So specifically to the charge of the nanobubble itself and the ability to remove various kinds of particulates and what we say generally as inhibitory compounds from the water. So really it's tied to physical properties of the bubble itself and their way to enhance different processes. And that can mean everything from helping to remove unwanted bacteria, making sure that they're not attaching to surfaces within the cultivation system and disrupting those biological matrices from those surfaces, as well as enhancing particulate removal and then looking at other things like whether it be protein skimming, emulsion breaking, and removing proteins from those waters, specifically looking at the nanobubble as sort of a non-chemical coagulant effect and helping to remove those. And then as well as to promote things like ozonation, delivering ozone through nanobubbles. Some of the research has indicated that it can have certain immune responses within the plants. I mean, within the fish or the animals that we're treating. And so as an overall thing, it certainly is promoting the welfare and water conditions in different ways that go beyond just dissolved oxygen.
Can nanobubble technology be applied in biofloc production systems?
Yes, it can, and specifically in terms of improving the biokinetics of that flock and making sure that they are active. And if you were looking at the oxygen uptake rate of that biofloc, we would see an improvement. So we do use this technology very consistently in various kinds of water treatments where you're using it in activated sludge. And typically, if you're looking at the biokinetics of that sludge in terms of, and if you were looking at the oxygen uptake rate, we typically see anywhere between a 15 to 20% improvement in the efficiency there. So definitely promoting the health of biofloc is a big proponent of what the nanobubbles can do.
What is the benefit of injecting ozone through your nanobubble generator?
So specifically relative to the gas transfer, so efficiently getting that gas dissolved immediately into solution. So if you're looking at the rate of ozone dissolution, you would see an improvement over a typical Venturi system, which is the most common way of introducing ozone. And then specifically the half-life of that ozone once in solution. And going back to tie to the efficiency is if you can immediately do it without pressurizing it, you have an improvement from the energy efficiency side, but most importantly from a health and safety. You'll see, if you notice in the presentation, that one graph talking about off-gassing. When we inject it through the nanobubble, you see a substantial reduction in the off-gassing from that ozone. So if you've ever worked with ozone and you can smell it in the environment, that is a health and safety concern. You don't want to be smelling ozone. You're typically over the limit. So while there's certain benefits to using ozone from an oxidation standpoint, you definitely don't want to be having your workers be smelling it. That's definitely a health and safety concern. So not only maximizing the treatment potential of the ozone, but also specifically addressing health and safety concerns.